recording now. You'll get a link to it after the webinar, and if you have a coworker who needs to see it, you can forward that link to them. So welcome, I'm Ryan Holger with Temperature Equipment Corporation. If you guys have any questions as we go, please type them down in the chat/question box, and I'll do my best job to take a look at those every few minutes and answer any questions that come up. So today, we are going to be going through the new Indiana residential code as related to energy conservation and as related to HVAC. There are a lot of other aspects to the code, but that's what we're going to focus on for today's discussion. So as you probably know, the HVAC industry is already highly regulated. We get pinched from all different directions, if you will, from Department of Energy, EPA, local codes, state codes. There's always rules that are being implemented at various points in time. As you probably are aware, we have another refrigerant change coming up in a couple years. We have another residential efficiency condensing unit change coming up in a couple years. So lots of big changes on the horizon. Illinois code will change again in 2 years. But today, Indiana residential code. So what is the new Indiana residential code? Indiana has specifically adopted the International Residential Code. What is that? That is a collection of a lot of the I codes meaning ICC codes, a lot of those codes bundled together into one code book. So in some respects, it's beautiful because everybody is following the codes that are meant to be used together, as opposed to adopting someone's mechanical code and somebody else's energy code and then saying, why don't they play nice? This is all one thing. So that went into effect in Indiana on December 26th. I think it passed on like December 25th and went into effect the next day, which is crazy. Usually there's some kind of leeway. This time, no leeway. So it is in effect immediately. It'll be implemented on your specific projects at the time you pull a permit. So if you pull the permit in November and it was approved and you're building it today, you're fine. If you pull a permit on December 27th, it's got to be under the new code. So specifically, this IRC 2018 code applies to 1 and 2 family dwellings only. It does not apply to larger homes like a condo building, and it does not apply to anything commercial. That's all different discussion. In the IRC itself, it includes the entire International Energy Conservation Code, or at least the residential chapters of that specific code. So that's what we're going to be working on today. If you want that for free, you can read it there. I will post that link as well as a few other links in the chat box for you guys at one of the breaks or at the end today. So you don't have to write it all down. I'll post it in there and you can just copy it or click on it. There's Indiana amendments. I will also give you that link. Right? So you need to know what's in the base code, the international code, and then you need to know what Indiana has changed. Unfortunately, the amendments are like 150 pages long, so it's a little bit crazy, but it involves so many different codes. Fire code, mechanical code, ventilation code, energy code, plumbing code, electrical code. So that's why there's so many pages of amendments. Commercial, if you guys deal with commercial stuff, nothing's different for you right now. You don't have to do anything different. We're still using the same commercial energy code that we've used in Indiana for a decade. So nothing happens there. This is just residential 1 and 2 family dwellings. If you're not aware, the International Energy Conservation Code is a widely adopted code, obviously internationally, but especially here in the Midwest. ICC writes that code. It is a collection of all the building inspectors as well as other interested parties. You may have heard of BOCA, or if you've done work in other areas of the country, some of these other acronyms. Those guys all merged together 20 years ago and made ICC, so that way the whole country and the whole world, if they wanted to, can use the same code books, which is awesome. The IECC is on a 3-year publication cycle. So right now we're working with the 2018 version, and then shortly the 2021 version will come out. Geographically here in the Midwest, this just gives you a snapshot of residential energy code. Indiana has the stripes on it because at the time this drawing was made, it was in progress. Now it is in fact live, so Indiana would switch to a green colored state if whoever made this map updated it. And I'm too lazy to update it myself, so hence that's why I'm still using this one. But Indiana would be green on this particular drawing if we redid it today. Michigan is on the 2015 code, and residentially it is virtually identical to the 2018 residentially. So Illinois, Indiana, and Michigan are pretty much, and Ohio are pretty much following the same rules. So pretty much wherever you're doing business in Indiana, if you jump over the border into a neighboring state, your rules are probably going to be basically the same. So that's kind of nice from a business standpoint. Commercially, like I said, Indiana's behind. It's nowhere near the current codes, so we're not going to talk about that today at all. So 2019, December 26th is when this goes into effect for residential in Indiana. Illinois, it went into effect back in the summer. Wisconsin is only on the commercial code, not the residential, and Michigan's only on the residential, not the commercial. So it's just kind of a little bit of a hodgepodge there. So one of the questions that always comes up whenever we do any energy code discussions is, when does this apply? Because there's a false belief that this code, or any of these codes, only apply to new construction, and that is definitely not the case. It is for new construction and existing buildings. Now, there are some exceptions for various types of existing buildings, but the exceptions are extremely rare. And specifically, if you read the code and pull up various sections of the code, whether it's residential, commercial, whatever, all these different exceptions will always tell you that you still have to go ahead and do the HVAC related stuff. So yeah, there's some weird exceptions for roofs and stuff like that, but HVAC, there's pretty much no exceptions. You always have to follow the code. Now, what does that mean? Does that mean you have to go back to every single building in the whole country or the whole state and redo it? No, of course not. Only the things that you're touching, you have to bring up to code. So if you pull a permit to replace a furnace, that furnace and the things attached to that furnace have to comply with code. But you don't have to go update the lighting. You don't have to go update the condensing unit. You don't have to update smoke detectors. Just the thing that you're working on has to be brought up to code. So if you install a new furnace, you don't have to make all the ductwork comply with code. But if you install a new furnace and you run a 12-foot duct run to a special area, that 12-foot duct run will have to comply with code, but not all of the other duct runs. The only exception that really comes into play, realistically speaking, is the one for historic buildings. If you have an historic building status and you can demonstrate to the code inspector that you can't do a certain thing in the code because it will ruin the historic nature of that thing, then you would not have to do it. For example, you may have some really beautiful stained glass windows or something weird like that, and it's part of the historic building and the building's registered as a historic building. They might not make you go ahead and put in some kind of freaky double pane stained glass windows. All right, but other than that, we got to do all the stuff in the book. All right, hopefully everybody got that. Like I said, if you have any questions as we're going, type them in, and I will do my best to answer all of those questions. So specifically, the residential provisions as related to HVAC for the 2018 IECC and hence the Indiana State Code. From the control standpoint, programmable thermostats are mandatory. You are not allowed to legally install a non-programmable thermostat. I understand people do that. I get it. But everything has to be a programmable thermostat. Some older versions of IECC had exceptions for radiant systems. Those exceptions no longer exist. So literally everything that has a thermostat that you put on it, that thermostat has to be programmable thermostats. So you shouldn't even have non-programmable on your trucks anymore. When you do set that thermostat up initially, you're required by code to not make the heating set point any higher than 70 and not make the cooling set point any lower than 78. It's kind of a worthless provision in the code because then the homeowner does whatever they want anyway 20 minutes later. But that's where you're supposed to try to set it initially. 78 may sound pretty high to some of you guys. I'll explain in a little bit why 78 is not high at all. But you probably won't get that till we get to that point. If you're doing a heat pump with supplementary heat, you have to have controls that interlock it to the rest of the heating system, so that way you don't run, cooling with heating and stuff like that. The boiler, if you have a boiler system residentially, it has to have outdoor air reset on it. That should not be a surprise anyway, because since 2012, all boilers nationally have to have outside air reset. So you should already be doing this, and if you're not, you've been doing it wrong from the national perspective. But now it's also happens to be in the local code, so it should be easier for the inspectors to notice and enforce, assuming that you want your inspector to notice and enforce things. Snow melt systems, you cannot have your snow melt system or ice melt system running wild. These have to be controlled. Specifically, it details what you have to do here. You have to be able to shut off the system when the pavement is above 50 degrees. So when you're installing this, you got to put a pavement sensor in. Obviously, if you're replacing a boiler on an existing snow melt system, Yes, the new boiler would have to comply with code, but you're not going to have to go cut the pavement up and put this particular sensor in, because that would be existing stuff that you're not touching. But if you're putting in a new snow melt system and pouring the concrete, you need to have that slab sensor in there. You also need to have a sensor that detects moisture, so it knows if it's raining or snowing. And the sensor doesn't care if it's raining or snowing, but if it's raining and it's above 40 degrees, you're not going to run it. So you got to look at pavement temperature. Is it above 50? Shut it off. If there's no precipitation falling, shut it off. And if the outdoor temperature is above 40, shut it off. So you got to have 3 different sensors on a snow melt system, because it is pretty easy to have a manual snow melt system that you turn on with a switch and you absolutely forget you flicked it on until you get your gas bill, 30 days later, and then you're like, what the? So that's why this provision is in there. Duct systems. All right, so we got a couple different things that relate to the duct systems. And once again, type your questions in. So far, nobody has done that, so I'm assuming right now you have no questions. Hopefully you can still hear me. That would also explain why you wouldn't have questions. For duct systems sometimes need to be insulated. So what do they have to be insulated for? For normal size ducts, we're going to have R8 insulation in the attic for both supply and return. If your ductwork is in the crawl spaces, it needs to be R6 insulated. If your ductwork is inside the thermal envelope, in the middle of your house somewhere, you do not have to insulate it. You may want to, but you do not have to. But attics you have to insulate, crawl spaces, exterior walls, things like that have to be insulated. So anything that's outside the thermal envelope has to be R6, except the attic has to be R8 instead of R6 from an insulation standpoint, both supply and return ducts. If you have really, really small ducts under 3 inches, then you can see up top there the requirements are relaxed a little bit because of the practicality of insulating really tiny ductwork, and the surface area doesn't have as much energy savings. In addition to ductwork being insulated, ductwork has to be sealed. Well, which ductwork has to be sealed? All ductwork has to be sealed. The whole entire project, you have to seal all of the ductwork. It is not optional. So specifically, ducts have to be sealed, air handlers have to be sealed, filter boxes have to be sealed. All the joints and seams have to be sealed and comply with the local mechanical codes. In the case of Indiana, the local mechanical code is the IRC, so it is in sync with this code. Let's keep moving along here. If your ductwork, I'm not going to read you all the text on here. This text is on here in case somebody has a question or something like that. We can refer to it. I'm not going to read you the code language because that would be super boring. I'm just giving you my interpretation of it. If the ductwork goes outside the thermal envelope, meaning it goes into an attic, crawl space, exterior wall, something like that. If it goes outside the thermal envelope, it still has to be sealed inside or outside the envelope. It still has to be sealed, but then it also has to be duct leakage tested. It has to be pressure tested to prove that it gets down to a certain leakage rate. The leakage rates are pretty aggressive. So you get either, I thought I highlighted, I didn't. You either get 3 CFM or 4 CFM per every 100 square foot of floor area. The 3 versus 4 number. The 3 number would be if your air handler, i.e. your furnace, is not yet installed. If your furnace or air handler is installed, you get 4 instead of 3 because they know the air handler is going to leak a little bit. Honestly, most of the furnaces and air handlers leak a little bit more than 1, so you're better off on a new install doing the duct testing prior to putting the air handler in. But in any case, you get 3 or 4 CFM for every 100 square foot of home. So if you had a 2,000 square foot home, that would give you 20 times 4. You'd have a maximum of 80 CFM of leakage if your air handler was installed. 60 CFM, if you're multiplying by 3 instead of 4, if your air handler wasn't installed. That's a pretty low number. That's a really, really tight duct system. So you're going to have to be pretty aggressive on the duct sealing effort. Obviously, at TEC, we support AeroSeal. It is reasonably easy to get to these numbers with an AeroSeal type system, but I know everybody doesn't have that equipment to do that. But if you are an AeroSeal dealer, this should be a great opportunity for you, and you may want to partner up with other contractors in the area who are having trouble manually sealing it down to the required leakage rates. So once again, all ductwork must be sealed. Ductwork only has to be tested if it goes outside the envelope. And that's if any of the ductwork goes outside the envelope. So If you have everything inside the house, all the ductwork's interior, and then for whatever reason you have to jump up into the attic, go down 6 feet, and then jump back down into one of the spaces, because you did that for that 6 feet, you now have to pressure test all of the ductwork. So it makes it a little bit more work, obviously. So they want you to put it all inside the building. That way, if it leaks, it at least leaks into the house. Granted, you won't get the right cooling and heating in the right room, but at least the energy's in the house somewhere. By the way, I should mention for the guys that are in other states, Illinois and Michigan, everything we're talking about right now applies to you also. So it's not just when you come over the border into Indiana to do a job. It applies in your states as well. If anybody has any questions on the duct sealing, go ahead and type it in. We'll do our best job to answer that stuff. This is fairly new for 2018. So for you guys that are familiar with the 2015 code, this entire section did not previously exist. It's a little bit elaborate in how it's all worded, but essentially what it's saying is that the ductwork, if you put it under the insulation of the attic, it may or may not be inside the thermal envelope, because the thermal envelope is both insulation and air tightness related for the home itself. So you have to pay attention if you're going to try to not insulate attic ductwork and then claim that the attic insulation is in fact also the insulation for the ductwork. My suggestion to you is try not to put the ducts in the attic, and if you do put them in the attic, buy insulated ductwork if it's flex. If it's not flex, insulate it, and then after that's all said and done, then insulate the attic like normal. That's the cleanest way to do it, and then you have to think about hardly any of this stuff here on this page at all. All right. Piping systems. Just like ductwork, piping systems need to be insulated. What are the rules for insulating them? So if you see up there at the top, any mechanical piping. What's mechanical piping? It's boilers, chillers, refrigerant lines, things like that, right? So any mechanical piping that's carrying a fluid, meaning water, refrigerant, etc., water and glycol. If the temperature of the fluid is above 105 degrees, i.e. it is heated fluid, then you have to insulate. If it's below 55 degrees, i.e. it is cooled fluid, then you have to insulate it, right? So specifically, if you want to make the interpretation, I would say every boiler for both the supply and return piping needs to be insulated, with perhaps the exception of radiant floor systems, because they might not be above 105 degrees, and they're certainly not below 55. So for radiant floor systems and the distribution piping to those floor systems, you would not have to insulate if you keep it below 105. But all of your regular boiler jobs that are going to radiators, baseboard, air handlers, stuff like that, you probably got above 105 degree supply, so you're going to have to insulate that in those cases. My note on the left there says needed for boiler supply and return water piping. It probably should say needed for boiler supply piping if it's high temp, needed for return piping only on a snow melt system. I didn't do a good job with my notes on the left there. I apologize. A normal boiler system, radiant floor, radiator, baseboard, etc., you're not going to be below 55. Well, okay, let me step back. You're going to be above the 105. So let's just do it this way. My apologies. I'll make it real simple. If you have radiators, baseboard, or air handlers fed by a boiler, both the supply and return will have to be insulated because they're above 105. If you have a radiant floor, both the supply and return will be between 55 and 105, so you do not have to insulate. If you have a snow melt system, your supply will probably be above 105 and your return will probably be below 55, so you have to insulate both of those. Obviously not the concrete, because that's the radiator, but the piping to it. Hopefully that makes it clear. Refrigerant systems, you're going to have to insulate those as well for your liquid and suction lines. They're very likely going to be above 105 and below 55. When you're doing this insulation, the code requires you have an R3 insulation. A lot of the manufacturers of the insulation for refrigerant line sets are not good about telling you the R value. So you got to go dig around in their tables to figure it out. As a general visual way to think about it, usually for like Armaflex type stuff, 1/2 inch insulation is what you're going to need to get to an R3. So that may be more insulation than you're used to putting on there. We do have a couple questions that came in. Roger asks if we can get a copy of all of this. Yes, I'm recording this, and that will help you as well. And then if you need me to send you any kind of slides or whatever, my email is going to be at the end of the presentation. Send me an email, and I'll reply back to you. That'll probably be easier than you guys all typing in your contact info or something weird like that. Terry asks, insulated within the envelope, question mark. But I don't know exactly what I was talking about at the time Terry wrote that question. So I'm not sure what that was related to. So let me know, Terry, what you meant. If we're talking about refrigerant piping or if we're talking about ductwork, and I'll try to figure out the answer to that. Terry says for boiler insulation. It is irregardless of the location of the piping. Inside the envelope or outside the envelope, I'm going to have to insulate the piping. All piping if the temperature is above 105 or below 55. If it happens to be outdoors, then in that case, I'm going to have insulation that's, UV resistant and so forth. It actually even says it on the code here. Brian asks, are line set manufacturers going to start selling line sets with insulation? They already do sell that. That is a widely available thing from the manufacturers. I don't know if each distributor, including my own distributor, stocks that with regularity. But I know we definitely do that because for a lot of like the ductless mini split systems, we already have to insulate both line sets as a requirement for those. Because on a heat pump, you normally wanted to insulate both anyway, even unrelated to code, because the temperatures on the heat pump for the opposite modes, it helps preserve some of that heat. All right, next topic. As part of the Energy Conservation Code, load calculations are a code requirement. You have to do ACA Manual J load calculations. Or if you have another load calc method, you have to have your local authority having jurisdiction, so your local inspector, approve your method. Or just go ahead and use Manual J like everybody else does. So you have to use ACA Manual J to calculate your loads, and you have to use ACA Manual S. If you're not familiar with Manual S takes your Manual J load and helps you apply that so you get a piece of equipment that will actually meet that load. It's especially complicated for cooling because you're going to have a sensible and latent load. You can't simply add those two things together and say, oh, I need 3 tons of cooling, and then go find a 3-ton unit. You got to find a 3-ton unit that will meet the sensible load and meet the latent load portion of what you're talking about. So ACA Manual S helps you apply the Manual J to a piece of equipment. S stands for selection in this case. At least that's what I pretend it stands for. As part of this discussion, the Energy Code requires you to not heat the structure, or at least not design the structure to be heated above 72 degrees. If your customer says, I want to heat it to 75, you're not allowed to design it that way by code. And you're not allowed to design it to cool below 75. So if your customer says, man, I really want to hang meat in here, I want it to be like 67 degrees in here all the time, you're not allowed to legally design that. 75 is what you have to design for as a low end on the cooling side. You can make it higher than 75, but you probably wouldn't. So that kind of goes along with those set points. You can't set the set points on the thermostat for startup between 70 and 78. And here you can't design between 72 and 75. So 78 sounds kind of high to a lot of you for cooling. 75 might even sound high. That is because you, not you personally, but you, the industry, has been oversizing equipment for so many decades that it's caused a very specific problem. When the equipment is oversized, it does not get a long run cycle, meaning the thermostat turns it on, 3, 4, 5 minutes later, it meets set point and it turns off. What ends up happening in that scenario is we don't get very good dehumidification. We need a long run cycle to dehumidify. Because when your air conditioner first turns on, it's lowering the temperature of your evaporator coil. And until I get the evaporator coil down to the dew point temperature, I don't start pulling moisture out. It's going to take me more than 3 to 5 minutes for that to really happen. So I need like 10, 15, 20-minute minimum run cycles on cooling to get some decent dehumidification. That means I can't have oversized equipment. How often are systems oversized? 100% of the time. It's probably 99 point something, but it rounds off to 100% of the time. Anybody who's been on any of my classes before knows that this comes up every class for boilers, chillers, AC, furnaces. Everything is badly, badly, badly oversized. So if you somehow do a good load calc and stop oversizing, all of a sudden a higher temperature is going to be more comfortable for people because it'll be dehumidified better. So in my house, we keep it at 77 or 78 degrees. Not because we like it warm or anything like that. just because it's ultra dry in my house in the summer, 30s and 40%, whereas everybody else's house around in my neighborhood is in the 60s and 70%. So they have to have a really cold temperature in order to drive their humidity down. In any case, the code requires you to do the load calc. It requires you to load calc with these temperatures that we have specified here for indoor design conditions. It also has requirements for the outdoor design conditions. It refers you to using the ACCA Manual J weather. So this is out of the 2014 ACCA Manual J weather document. These are all of the weather stations for Indiana that we're talking about specifically. I highlighted South Bend just so we can have an example here. So for South Bend, the heating design temperature is 5 degrees. If you're using 0 or you're using -5 or -10, you are not even relatively close. Does that mean it's never below 5 degrees in South Bend? No, of course it can get below 5 degrees in South Bend. But statistically, it's not below 5 degrees very many hours. So that's what we're going to design for, fit 5 degrees on the heating side. And up at the top of the column where it says heating 99%, that means 99% of the hours it'll be above 55 degrees in South Bend, Indiana. Only 1% of the time will it ever be below 5 degrees on a 30-year rolling average. On the cooling side of the equation, it works the same way. Instead of 99%, it says 1%, but it means the same thing. It's just because if you imagine a bell curve of all the temperature weather data for the year, 1% on this side, 99% on that side, it means the same thing. So 1% of the time, it'll be above 88 degrees in South Bend. Our code required design outdoor temperature for South Bend is 88 degrees. And if you're working in a different area, you can see the chart here. Most of them are pretty similar for you guys because most of you guys are in northern Indiana. Hobart, for example, 2 degrees is your summer or your winter design, 88 is your summer. If somebody was down in Indy, it'd be 6 and 89, right? If you get really far down, Evansville, very tip of the state where it's most likely to be the warmest, 12 degrees and 92 is your design. So you can see how that kind of works there. All right, so with that being said, this is what's required by ACCA Manual J, and ACCA Manual J is required by the state code. However, for the heating side of the equation, Indiana has an amendment. Remember I mentioned there's 150 pages of amendments. This is one of those such amendments. The Indiana amendment, there is an Indiana amendment for the heating outdoor weather design data. It's like 4 pages long because it's for every single county. So I did not screenshot it and put it all on here. But you can just see that column where it says winter design temp. All of the counties in the northwestern portion of Indiana, right? So Lake, the examples I gave before, if you were doing a job in Hobart or South Bend, right? So if we go back to South Bend, 5 degrees, the state amendment is 1 degree. So even though the load calc is supposed to be based on 5, in Indiana for South Bend, you would make it 1 degree instead. So you're getting a little bit of extra buffer there. I assume that's in response to some kind of panic related to the polar vortex last year or something. Everything in the northwest half of the state says 1 degree. Everything on the whole entire 4 pages of tables in the amendments says 1, 2, or 9 degrees. So if you're in the northern half of the state, it's 1. If you're in the middle, it's 2. If you're in the southern, it's 9. Obviously, refer to the document to find out where your exact county happens to be. All right, any more questions on that? Oh, I should have put this slide earlier. This is the bell curve I was talking about. So if I look at, once again, I picked South Bend as my example just to pick something. I apologize if you're in a different area. But looking down at the low end of the equation, how often is it really below 5 degrees in South Bend? Not very often. It's pretty minimal. And if you look down below 0 degrees, it's like a little tiny line over there. It's really small. Same thing on the high end. How often is it above 88 degrees? Very, very, very small portion of hours of the year. So that's why we don't design for those peaks, because it ends up giving us equipment that's 1, 1.5, 2 tons bigger than it needs to be, which means it's really horrific at dehumidification. I'd rather have my cooling be awesome on all of those hours where it's 75, 80, 85 degrees and have it be teensy bit undersized on the 90-degree day, meaning that the customer can't get their set point down to 74. They can only get it down to 74.2 or whatever number you pick. All right, since there's no questions being typed in right now, I'm going to keep on trucking along. The energy code actually has a requirement for mechanical ventilation, which is sort of kind of weird. But there are some aspects of the energy code, actually there's a lot of aspects of the energy code that are not related to HVAC, but some of those things affect HVAC. Obviously, the better the windows and the better the insulation and the better the roof they make you put in, that changes your HVAC load. But one of the other things that happens with this code is that the building, the whole entire home, must also be sealed, and it must be pressure tested to see if the building envelope leaks and how much it leaks, and then has to get down to a certain leakage rate. I believe it's 3 air changes per hour tested at 50 pascals. But that's a separate webinar. But because the building is going to be so tight, they don't want the building to be starving for fresh air, and people can't get fresh air to remain healthy. So they make you make the house really tight, then they make you punch a hole in the side of the house and suck ventilation air in. In some respects, you're like, what the hell? Why would we do that? Like, let's just leave the house leaky. But when it's leaky, that causes drafts and things to blow across people, and they compensate that by jacking up their thermostat. What I want to do is make the house super tight, bring all of the air through one single controlled hole that I can then heat, cool, humidify, dehumidify, and filter, and then bring it to the space. So it's really more of a control thing than anything else. So you have to have the mechanical ventilation. It is required. Every HVAC system that you install, you're going to have to put a mechanical ventilation system in. It does not specify what kind of system you can have. So you can do an exhaust-only system. I would highly recommend against that. That basically means you put in a bunch of oversized bath fans and just run them 24/7. Puts the house under negative pressure, which means air sucks in whatever cracks are left in the house. But unfortunately, that drives water into the wall assembly. It brings dirt in. It's not ideal. Nobody thinks exhaust ventilation is a good idea except for the manufacturers of bath exhaust fans. Everybody else thinks it's a horrible idea. So don't do it that way. You could do supply only, which means I have a duct coming in with a little booster fan or something, bringing air into the house and positively pressurizing it that way. I could do that. I could also do supply only by not buying a booster fan and running a 6 or 8 inch duct, depending on the size I need, over to the return of my furnace, and then running my furnace fan all the time, 24/7. Right, so I lock the furnace fan on, and I suck fresh air in through both my outside duct and my return duct. That's the most common way to do it by far. If you do it that way, your air handler, i.e. your furnace, has to have an ECM motor. This was something we had to point out and force people to do with the Michigan and Indiana, or Michigan and Illinois codes. It's not going to be a big deal for Indiana because, as you know, as of July 4th, I believe, last year, the manufacturers of furnaces now have to make all the furnaces with ECMs as the lowest entry point motor. So very shortly, you won't be able to find a PSC motor at your distributor anymore. So the problem just kind of goes away and takes care of itself. John is typing in a question: is ventilation required for furnace boiler replacement? So just to be clear on two things. One, right now I'm talking about fresh air for the home, not combustion air. Combustion air is going to be a separate requirement that may or may not be needed for your furnace, depending on whether it's separated combustion or not. Right now, what we're talking about is just the ventilation air, and I assume that's what John's also asking about. So what he's asking about is, if I do a furnace change out, am I going to have to put an outside air duct in? The way the code is written, the answer would be yes, you would have to do that. Now, the way it's been enforced, where I live in Illinois, is the inspectors are not enforcing that. Right or wrong, they're just not doing that. Probably because they think it's pretty impractical, depending on the location of the furnace. New construction, absolutely no-brainer. A gut rehab, absolutely no-brainer. On a furnace change-out, your inspector probably won't make you do it, but you should be doing it per the letter of the law of the code. If you know that they just sealed the house up as well and made it tight, you definitely want to find a way to do it. Otherwise, people are going to have problems in general. So hopefully that answers your question, John. So if you're using the furnace or other air handler, it's got to have an ECM motor. If you're using a different type of system to bring the air in, then there's some specifications down on the bottom of the screen there on how efficient that piece of equipment would have to be. So I said you could do exhaust only, bad idea. Supply only, most common. You could also do a balance system where I have exhaust going out and supply coming in. And the idea there is I keep the house pressure neutral compared to the outdoors, and I don't have any problem with wind coming in and things like that. If you're going to do that, you're probably doing that with an HRV or an ERV. And in our climate, you're going to want an ERV. HRVs would be further north, like more towards Canada. You might want to use an HRV, but down here, you want an ERV, so you get the benefits of both the sensible and latent energy recovery or rejection. And we have to do a whole other separate webinar on how ERVs work. But an ERV would be one way to comply with this as well. If you are going to use an HRV or ERV, do not take the exhaust air out of the return duct of the furnace. Do not take the exhaust air out of the return duct of the furnace. When you do that on any project, it'll cost more to operate the ERV than if you've done nothing. It does not save you any energy. You have to take the exhaust air from places that you wanted to throw the air away anyway. So specifically on a residential, you're going to run the exhaust for the ERV from the bathrooms, and then if you need a little bit more, maybe from like a hallway or something like that. You don't buy bath fans. You don't put them in the bathrooms. You put a register there and a duct, and you run that duct over to the HRV because that's the air that was going to be trash anyway. And you recover the energy out of that air, transfer it to your ventilation air. If you need help with that, let me know. We can do a discussion on that. I mentioned effective July, I said 4th, it was July 3rd. You have to have ECM motors essentially anyway. So this requirement over here for this ECM motor on a furnace when it's used for ventilation kind of takes care of itself by the national standard anyway. And I think all of you guys are probably aware of that. We refer to it as FER because that is the efficiency rating metric. It doesn't specifically ban PSC motors or require ECMs, but with the given technology we have for furnaces, the only way to comply is to go to an ECM and stop using a PSC. So that's kind of the way it's been being handled. So the best thing to do is if you want to comply with code, which hopefully you do, some of your competitors may not be complying right away because they may not know the code. Maybe they didn't sit on my webinar. So send them a link to the recorded webinar. No, I'm just kidding. And your inspector may not know the code yet either. Even though the inspector doesn't know the code or doesn't police it, doesn't mean you don't have to do it. You are still legally liable to comply with the code. Even if the inspector said, you know what, Ryan, you don't have to do anything in the code book. I don't care. He can't legally say that. He may have done it, but he can't. And you still have to comply. So the best thing for you to do is make sure your clients know there's a code. If you're bidding something and when you're bidding it, the code change requires your price to be a little bit higher, like duct sealing better or whatever, make sure the customer understands that. So when they get other bids, which they're probably going to do, they can compare apples to apples and they're not just like yelling at you for being a high price, really make the other guy, the competitor's price come up to yours. So if I was to summarize all of the things that we talked about, plus a couple things that I forgot to mention, this one page here would be your complete summary of all the stuff you need to pay attention to as energy-related HVAC as part of the Indiana IRC. I didn't mention it, but I should have. You can no longer use the building cavity as part of your duct system. So that means you cannot have pan returns, you can't use drywall. Everything that you run air through, supply or return duct, has to be actual duct work. You can use flex, you can use sheet metal, you can use the, I forget what that fiberboard's called. I can't remember what it's called. Whatever that is, you can use that, but you can't use the building cavity. You cannot use the wall cavity as your return duct. That's no longer allowed. You can't put a piece of foil panning or metal panning on the bottom joist in the basement and use the two studs and the floor as the other sides of the duct. Not allowed. It's got to be all fully ducted. I mentioned you got to insulate ducts when they go outside the thermal envelope. So attics are 8, other spaces are 6. All ducts have to be sealed. If the ductwork goes outside the thermal envelope, you got to pressure leak test it to prove you sealed it well. You have to do manual J load calcs. You have to do manual S for sizing the equipment. You got to use the Indiana specific heating design temperatures for your county. And then for cooling, you use the ACCA manual J temperatures for your weather airport data city. Programmable stats you have to use. Boilers have to have outside air reset. You're going to be required to have ventilation air. If you're bringing that ventilation air through a furnace, it has to be an ECM. If you're bringing it through a fan or an ERV, then that fan or ERV has to have certain watts per CFM requirements met. Mechanical piping systems need to be insulated for both boilers, chillers, and AC line sets if your fluids are warm or cool. So probably the only realistic exception to that would be a radiant floor system. Could be between those two numbers. Here's some additional links for you guys. I'm going to take those first 2 links. Actually, I'm going to do this right now, or otherwise I'm going to forget. I'm going to take those first 2 links. I'm going to post them in the question chat box so you can simply cut and paste them and use them for whatever you want once I figure out how to put it in the question chat box. All right, so there's the first one for the International Residential Code. And then here's going to be the one for the Indiana amendments to that code. So those very first two, I put them in the question chat box. You can click on them there and they'll open up in your browser, or you can copy them and paste them somewhere else. If for some reason you can't figure it out in the chat box, just send me a note and I'll email it to you instead. So those are on there. Both of them are not fun to read, which is why I did this webinar. I boringly read all the code and then I made the webinar because it was easier for you guys. But it's there. If you don't believe me, or if you want to check something, or you want to dive deeper than I dove, you can do that there. And there's some additional resources on there for helping you out with energy codes across the country if you should need something. If there's any more questions, type them in here. I'm going to hang out for another minute or two, and I'll try to answer any questions that you have. If there's no other questions, that's fine too. I'll just give it a minute and see what pops up on here. All right, the only other question John said the second link is not working. Let me, you know what, John? It's a PDF, so it's opening up somewhere else on your computer, or it's automatically on your computer going into your download file. So before I close out, just copy that link and paste it somewhere, email, notepad, Word document, something, and you can go back to it later if you want. But I just clicked on it right now, and it in fact opened the PDF for me. But I have my computer set up to automatically open PDFs. Your browser may not be set up that way, so it may take a little bit more effort for you to get that. All right, since there are no other questions, the only other thing that came up a couple times here is folks wanted the copy of some of the documents. If you need anything at all that I presented, send me a note to ryan.holger@tecmungo.com, and I'll reply back to you with whatever it is that you were asking for. All right. Thank you guys for your time, and we'll see you on the next webinar. Bye.